So we continue with the elements of an aircraft. Spoilers are used to decrease lift force, but at the same time they increase drag force as well. So they effectively cause the aircraft to slow down. So if you are while flying, if you need to decrease your speed, you can use the spoilers. And one place they are used is right after landing. So when the aircraft lands, when the wheels touch the runway, you want your aircraft to slow down as quickly as possible. Okay, so if you can make your aircraft slow down faster, that means you can land on shorter runways, which is obviously a very good thing. So in this video, you see the operation of spoilers as well. Let me show that. So this is the same aircraft. This is just about to land. You already see the runway here. And this is after touchdown, you see the spoilers. So these are the spoilers. Okay, so see the spoilers just, they open. And they serve two purposes here. They create drag force, and drag force directly slows the aircraft. But also they reduce lift force, and once the lift force is reduced, the entire weight is carried by the wheels, and that makes the brakes more effective. So they use the brakes just like a car to slow down. And in this case, the spoiler operation is automatic, so the pilot doesn't have to turn on spoilers manually. So as soon as the wheels touch on the runway, the spoilers are deployed automatically. Okay, so you see they just open, and so it's already very slowed down quite a bit, and now they're just retracted again. And so are the flaps. The flaps are retracted.
Although we are on the ground, we want to make sure you are absolutely safe remaining in your seats until the captain.
So here you see a diagram explaining how they work. So this will make more sense once I explain how the lift force is created. But anyways, normally you have this airflow around your wing section, and if you open up your spoilers, it causes the airflow to be deflected that way, and this is how you reduce the lift force and increase the drag force. So I said when the aircraft touches on the runway, the spoilers are deployed automatically, but if while flying the pilot needs to use them, so this is used for that. It says speed brake here, so the pilot can use this to use the spoilers while flying. So there are a few more elements here, so these are not really critical for our purposes. So I will just quickly pass these. This is called the radome, the nose part. The word radome comes from the combination of two words, radar and dome. So most aircraft have a radar at the nose, and it's covered with this shape, which is called radome. So this is the landing gear. This is the structure used to support the aircraft while on the ground. So while flying, the weight is supported by the aerodynamic lift force, but when on the runway, you still have the weight of the aircraft, and the weight is balanced by the forces coming from the landing gears. They support an aircraft on the ground and allow it to taxi, take off, and land. And taxiing is the movement of an aircraft on the ground under its own power. So before taking off, while the aircraft is accelerating, weight is still carried by these landing gears. So let me see, I have some videos that I can show here. Okay, so let's take a look at this one. So this is a very nice video. There are a lot of interesting things to look at in this video, so I'm going to play it several times. Well, first you see that the aircraft is approaching in a funny way, right? So it's not flying straight, obviously. So this must be due to very heavy side winds. So there are strong winds coming sideways, and the aircraft needs to be aligned, the speed of the aircraft needs to be aligned with the runway direction, but under such heavy side winds, the aircraft nose has to be pointed that way. So the landing gears are really one of the very important parts of an airplane because they support the aircraft when on the ground. But as you see in this case, while landing, they have to withstand very large forces because the aircraft is coming down with some speed, and when it just hits the ground, momentarily very large loads are created on the landing gears, and they have to be able to withstand such loads. And you can see that in this video, when the wheels touch the ground, and pay attention to the wings. See how the wings bend when it lands. So you can see the amount of forces on the landing gears by the oscillations on the wings. Also, let me ask you a question. Have you ever thought about why smoke comes out of the wheels when the aircraft touches the runway? So as a kid, I thought this was due to a bad landing. So I was thinking, okay, if the pilot can land properly, there shouldn't be any smoke coming out of it. But that's not really the case. Even with a perfect landing, there will always be this smoke coming out of the tires. So I like that we live in this age of internet because you can find anything you can imagine. So whenever I want to see something, I search for that, and most of the time I see a nice video showing that. So when I said, okay, maybe I can talk about that smoke coming out of the tires, I thought about showing a video showing what's happening at the instant of touchdown, and I found this video. This video shows the landing of a Boeing 777 aircraft recorded in slow motion. Okay, so the aircraft is just about to touch the runway, and as you see that the wheels are not rotating, right? They are all stationary. Okay, and the first moment the wheel touches the runway, the wheel is not rotating, but the aircraft has a speed, right? So therefore the wheel is stationary, but the runway is moving with respect to the aircraft. So therefore there's this slippage between the wheel skids on the runway. So with the effect of this force, the wheel starts rotating, but it takes some time for it to rotate because it has a certain inertia. It cannot really come to the correct speed immediately. So it slowly starts rotating, and until it reaches the correct speed, there will be this skid between the tire and the runway, and that causes this rubber to burn. And then the same thing happens for all the tires, obviously. Okay, so I have some actually more interesting things to show here. So what's that? So obviously the landing gears have to be strong enough to withstand a lot of different forces. But there's one other thing that you need to take into account, and that is if so before takeoff, the aircraft is stationary, right? And the pilot gives full throttle and it starts accelerating. So it speeds up, and when it comes to the correct speed, it can take off. But if for whatever reason the pilot has to abort takeoff, then he needs to slow down again, right? So the aircraft starts accelerating, comes to a certain speed, and then the pilot says, so we cannot take off, we should just abort takeoff. And then what happens is, obviously he needs to cut the throttle, so thrust force have to be removed. But the aircraft will still be traveling at a very high speed, and the aircraft needs to slow down as quickly as possible. And in that case, the wheels, the landing gear will be creating the braking force. So that's another reason why the landing gears have to be designed very strong. Let me show you another video about that. So this is the testing of the landing gear of this Boeing 777 aircraft. So this is just a test to see if the landing gear are strong enough or not. So if you design an aircraft to be able to fly it, you have to show to the authorities that your aircraft is safe and can be used to carry passengers, because so there are a series of tests, and one of these tests is this one here. So you have to show that it can safely slow down in case it needs to abort takeoff. So let's just watch this video.
As the plane taxied carefully back to the stand, several fire engines waited, counting the seconds until they could put out the flaming brakes and cool the wheels. Each tire had a fuse plug which melted at a certain temperature. Before the tires became so hot they exploded. All 12 wheels were destroyed at a cost of $750,000. But the plane didn't catch fire, and the brakes performed even better than expected. The test had put 9.7 million foot-pounds of energy into the brakes and shown that the plane could survive, almost intact.
Okay, so if you really think about the total energy that needs to be dissipated, so consider the aircraft, it's going at about 300 kilometers per hour, and imagine its mass. It's like, I don't know, 200 or 300,000 kilograms, and compute the kinetic energy it has at that point. Now, all that kinetic energy needs to go somewhere, right? And in this case, most of that energy goes into turns into heat on the brakes. And if you heard that the brake pads heat up to 3,000 degrees centigrade, and it's supposed to withstand for at least 5 minutes, because they say approximately it will take 5 minutes for the firefighters to reach the airplane. So this was a very successful test. So this is just one of the many tests an aircraft has to go through before being allowed to fly. Let's see. Now I have the same test done on Airbus A340. Let's quickly take a look at that one as well. So anyway, this was a pretty long test, but as you see, this was not as successful as the other one. So I think this is the same test recorded with a camera from outside. So anyway, let me just state here that I'm not really against Airbus. Hopefully these videos will not make you think that Airbus is less reliable compared to Boeing. It's just in this particular test, I guess they had to work harder to make the brakes more reliable. Okay, so in some case, well, in most commercial aircraft, the landing gears are wheels. But for other cases, you need floats. For example, on this one, this aircraft can land on water. So to be able to land on water, the landing gear is these two floats here. Or sometimes the aircraft can land on ice. In this case, they use these skids, for example. But they serve pretty much the same purpose. They have to support the weight of the aircraft, and they have to allow it to taxi. They have to allow the aircraft to increase speed while moving on the runway. Also, they have to withstand such extreme conditions for rejected takeoff, or while in a harsh landing, they have to be strong enough. Now let's see, I think I have. So this is a very old video showing this C-130 cargo airplane. I like this airplane a lot. So it's a pretty old design, but it was a very good design. Still today, a lot of countries are using this aircraft for various purposes. So I don't know when this video was recorded, but perhaps it was some 40 years ago. It could be even older than that. So this shows a very bad landing. In fact, some part of the wing just breaks. And as you see, even then, the wheels appear to be strong enough to survive. So if you pay attention, just the tip part of the right wing just falls off after landing. So look at this part. Okay, and then so there are some cockpit instruments. I'm going to really pass these very quickly. Well, the cockpit is the place where the pilots sit to operate the aircraft, and they have to make sure that the aircraft is flying safely. And there are a lot of things they have to check to make sure that everything is working properly. First of all, they need to make sure that the aircraft is flying normally, its speed, its altitude, its position. And they have to make sure that all the other subsystems are working properly. For example, this is, I think this is Boeing 747. There are a lot of electrical systems, right, for the passengers, the lighting systems, entertainment systems. Also, there are some hydraulic systems to operate the control surfaces. So all these things they have to be controlled and they have to be monitored. So the pilot has all these gauges and they need to check. So if you look at how complicated the cockpit is, there are a lot of things that needs attention. So the pilot needs to monitor each and every one of these things. So to make sure that it's flying properly. And obviously this depends on how complex the aircraft is. For such a simple, for a very simple aircraft, there are not many instruments. Remember that cockpit of the glider, there were just 2 or 3 displays, and that was it. But obviously for a large complex aircraft, there are many things. So the next picture is the cockpit of the Concorde aircraft, and look at how complicated the cockpit is. In fact, it is. There are so many systems that the Concorde has a third person here. So these are the pilot and the co-pilot chairs, and this chair is for the flight engineer, it was called. So the flight engineer, there's a third person whose job is just to make sure that all these additional systems are working properly. So this is just one reason why Concorde is not flying anymore, because it was too expensive to fly Concorde. So normally you have 2 pilots, but for the Concorde you have to have a highly skilled, highly trained flight engineer for every flight. Obviously that means more money needs to be paid. And obviously all these additional equipment needs maintenance as well. So some aircraft require this flight engineer, but nowadays with the development of the computers, most of these things are now automated. So these are all devices, all mechanical and analog devices that needs pilot's operation. But now you can computerize all these things. For example, there are many displays here that needs to be monitored. You can write the computer software to do all that, right? So if you look at today's modern aircraft, these old analog displays are replaced with computer screens. For example, if you look at here, these are all analog displays, right? These are all mechanical displays. But if you look at this aircraft here, now there are these computer screens instead of that. And obviously, once you have this computerized system, you can use that to check certain things as well. So the pilot does not need to check every single detail anymore. So this is these are called glass cockpits. So this is not a completely glass cockpit, because you still have these old displays together with computer screens. But if you look at this one here, this is a completely glass cockpit. So everything you see here is a computer screen. So even these small ones they are all computer screens, and everything is computerized. So these are some of the instruments that a pilot needs to check to see how he is flying. So this shows the altitude of the aircraft. So there are different ways you can measure the altitude of an aircraft. This one uses the pressure, outside pressure, to estimate the altitude. So it's not an exact measure, but it gives a close estimation. So if you go high in the atmosphere, the air pressure drops. So if you measure the pressure, from there you can estimate your altitude. So this shows the aircraft attitude, aircraft angular position with respect to the horizon. So if the aircraft has a rolling angle or a pitching angle, the pilot can see from this instrument. This shows the speed of an aircraft. Again, you can measure the speed by using different means. And this speedometer uses air pressure. So if you fly faster, then so anyway, I will be talking more about how the speed is measured. Let me just skip that for now. So this is to show again the orientation of the aircraft, like a compass. So, turn coordinator. Well, normally I talk a little bit about this turn coordination, but I'm not sure if I should do that now. So this shows the vertical speed. The previous This shows the forward speed, this one, and this shows the vertical speed. This is called the T arrangement. So this is pretty standard. So these instruments are placed in this order. So you have this artificial horizon here. So this shows the heading. This shows the speed, the altimeter. So there are many types of aircraft, right? So it would be really bad if every aircraft manufacturer placed the instruments differently. So there's a standard to that, and this is called the T arrangement. So if you design an aircraft, you cannot just put these displays arbitrarily. Otherwise, it would be too confusing for pilots who are used to flying different aircraft, right? So you have to follow this arrangement. Okay, now actually, I don't know if they really made this aircraft or not, but look at this aircraft. This is a small private aircraft. And it just looks like a car, right? It has such a simple cockpit. There are just 3 computer screens here, and there's just this little joystick and just a few buttons here. So compared to all the other small analog devices, everything is now computerized. This is the head-up display, this little screen here. Even some cars now have these head-up displays. The purpose of this thing is to give the pilot some necessary information without him having to look at the displays. So the pilot keeps looking through the window, and in front of him he sees some information regarding the operation of the aircraft. Okay, so this really covers the basic aircraft elements. So some of these are important for our course. So obviously this cockpit is just for general information. I will not be talking about the cockpit in the remainder of this course. Similarly, these displays, just for general information. I will explain how these work, how the altimeter and airspeed indicator works, how they use the pressure information to detect the speed and the altitude. But other than that, most of these instruments are really just for you to know as a general information about aircraft. So I said that these computerized cockpits, glass cockpits, have advantages. For example, you don't need to have a separate flight engineer because everything can be checked with computer software. But you know, computers have their own problems, right? And I read this, I think it was last year, but since everything is computerized, they are subject to computer failures. So this time you don't have to worry about mechanical perhaps, but now you have to worry about software errors. And there, obviously these aircraft have some problems from time to time. And there were some incidents where, I think they were also Airbus, where some Airbus aircraft lost everything in the cockpit. So the pilot lost everything. Every single display was shut off, including communications. He didn't even get the chance to talk to the airport people. So everything was